So in this video, we'll be looking at minimum and maximum values. Let's first remind ourselves of the type of minimum and maximum values. So firstly, f of x has an absolute or global maximum at x is equal to c if f of x is less than or equal to f of c for all x in the domain. Secondly, f of x has a relative or local maximum at x is equal to c if f of x is less than or equal to f of c for all x in some open interval around c. Then f of x has an absolute or global minimum at x is equal to c if f of x is greater than or equal to f of c for all x in the domain. And lastly, f of x has a local or relative minimum at x is equal to c if f of x is greater than or equal to f of c for all x in some open interval around x is equal to c. And that just means some interval ab where c is between a and b. So let's look at what these types of minimum and maximum values look like on a graph. And I've labeled the stationary points of this function f of x and the endpoints as a, b, c, d, and e. Let's start off with d. Here, our function value at x is equal to d, so f of d is going to be the highest function value we have defined on this domain. So this is in fact an absolute maximum. But because of the way a relative maximum is defined, it can also be classified as a relative maximum. Let's then look at x is equal to b. Here we also have a maximum, but it's not the same as the maximum, the absolute maximum we found in x is equal to d. So this would just be classified as a relative maximum. Now we can look at our minimum values. We have x is equal to a on the leftmost side over here. And this is the lowest function value we have defined on this interval between a and e. So this is in fact our absolute minimum and similarly our relative minimum. C, we have a relative minimum as well. And E, we also have a relative minimum. Okay, I think we should look at an example. So say we wanted to find the relative and absolute minimum and maximum values for f of x is equal to x squared on closed interval minus 1 to 2. There's generally 3 steps to do this in. Firstly, we need to find all the stationary points. Secondly, we need to classify these stationary points as minimum or maximum values using the second derivative test. And thirdly, we need to find the coordinates of all the points, including the endpoints, so that we can compare the maximum and minimum values that we found. So step 1, we need to find all our stationary points. If we take the derivative of f of x is equal to x squared, we'll find that f prime of x is equal to 2x. And if we wanted to find the stationary points, we need that to be equal to 0. And this just implies that x is equal to 0. So we have a stationary point at 0, 0. Okay, next step is to classify this stationary point as a minimum or maximum value. And we do that using the second derivative test. So if the second derivative of f of x is positive, then it's a minimum value, and if it's negative, then it's a maximum value. So let's take the second derivative of f of x. So f double prime of x is going to be equal to 2, which is in fact positive. So 0, 0 is now a minimum value. But is it a minimum value that's relative or absolutely minimum? We don't know. We need to check this. So now we need to evaluate all our points, including our endpoints. And so far we have 0, 0, and on the leftmost side we have x is equal to 1, minus 1, and on the rightmost side we have x is equal to 2. Our function value at x is equal to minus 1 will be equal to minus 1 squared, which is 1, and our function value at 2 will be 4. So now we can see that we have minus 1, 4, 2, minus 1, 1, 2, 4, and 0, 0. Okay, so 0, 0 is actually our only minimum value. So it is, in fact, an absolute and a relative minimum. Minus 1, 1 is a relative maximum defined on this interval. And 2, 4 is the relative and absolute maximum defined on the interval between minus 1 and 2. And that is minimum and maximum values.